I have the pleasure to introduce the first scenario, the first challenge, which is titled Reconfigurable Interactive Manufacturing Work Cell. Or actually, work cell should it read, it's a robot work cell. And in fact, what actually motivates us to bring this scenario forward, of course, we have the vision of using a robot as intuitively, as safely as we use today a power tool. And two characteristics are quite evident from the title, that we actually think about work cells which are used interactively, which means in a safe way, in a cooperative way, in also an informational, intuitive way, and that the work cell is reconfigurable. We also put the process of assembly into the focus. And if we look at today's robot application, industrial robot applications, we see that quite few, or relatively few, are actually used in assembly. And this has a meaning. This is because the assembly process, in terms of robotics, is quite complex. We need motions, but also motions which are influenced by tactile information, by compliance, etc. And this process, which is an encapsulation of tactile information, motion information, sensor information, is quite difficult to program or instruct. So that's why we are also looking into that process. So we will define scenarios, and as I already said, we'll put the adaptive perception, cognition skills into the focus. We will look for robust assembly, and of course also emphasize safe and productive human-robot interaction, especially when it comes to cooperative assembly. The aspect of workflow, of economic feasibility, profitability comes into play. So is the process really conducted in an effective way? So there's a perfect way to actually evaluate this in realistic scenarios. Another thing is that we also think about using more than one robot, multiple robots, that we have also robots act as a fixture, as a positioning tool, etc., and have the other process robot work as a process tool. So these are examples of the scenarios we'll be looking at. We'll take these scenarios out of industrial application scenarios. In fact, we will be running in Stuttgart, or we already started with that project more than a year ago, with a so-called ARENA 2036 scenario, which is actually a research factory. ARENA stands for Active Research Environment for the Next Generation of Automobiles. So it's a large initiative promoted by Daimler, Bosch, and many other automotive manufacturers, automotive supply manufacturers in the Stuttgart area. And one of the activities is that we are setting up a complete research factory. And in fact, we'll be taking use cases from that research factory on the one side, and also ask the teams to implement their solutions on workstations in that research factory. So we will have an extremely realistic demonstration and evaluation environment, which should of course also be attractive to other teams to get in contact with advanced automotive manufacturing. Also, part of the ARENA is that we provide state-of-the-art hardware of quite many manufacturers, both on the component side, also on the system side. Examples are listed here. So these teams will find a very rich set of hardware. Also, we will provide as EPA the glue to actually integrate components. ROS has been mentioned a couple of times yesterday, so we'll be offering that kind of interface for teams to integrate components. And of course also EPA will help and assist these teams to bring their integration or their solutions forward. Yeah, as Fraunhofer IPA will be soliciting for applications, of course. Also we will assist in the hardware setup, software integration, and all other works which come with robotics engineering and robotics use today. Yes, and contact persons are myself, is my colleague Rames Abad and my colleague Bernd Winkler, and I'm of course very much inviting you to consider participating in this challenging effort, I certainly can promise it will reach highest visibility.